All right, this is Mr. Diamond, and this time I'm going to be, this is that super secret extra method that I mentioned I might do a video about. As you can see, well, I guess if you're not seeing this, I gave up and decided not to post the video. So if you see this, that means I did decide to show it to you. Now, word of warning here, this concept is not, it's not that much more difficult, but if you want to skate by understanding only the like, oh, I logically, it makes sense to me that I could predict this speed and I know this, and like if that last calculation made 100% sense to you, and you don't want to have to think about it anymore, you can do that. But this is going to be a shortcut that takes a little bit more understanding of the actual concepts related to physics. It's not actually that much harder, but I don't want to confuse you, so if you're already feeling a little overwhelmed by that stuff, don't worry about it. This is an extra video. You've been warned. I'm going to work out the same example as before. So we've still got our ball. I'm going to presume it's launched by a spring, and it's going to get launched upwards at an initial velocity of 4.0 meters per second, and we want to know the time that it will stay in the air. Now, the last time we solved this, if I flip this over, we figured out all the stuff that we knew, we solved for our time, and then we ended up having to double that because of the fact that we used that it at the peak of its trajectory, it will have zero speed. And that is a very fundamental concept, an important concept, but there's another concept that we can use that's not as important for this chapter, so this is just kind of, again, this is a head start that you can have on one of the other chapters. But there's another concept we can use. So instead of considering, sounds like somebody's playing a game in the other room. Instead of considering the half trajectory, we're going to consider the full trajectory. So this time, we know that our velocity, our initial velocity, is 4.0 meters per second. That still stays the same. I apologize if that awkward pausing. There's like ice cream music playing outside my classroom right now. We know our acceleration is negative 9.8 meters per second squared. We know our initial point is 0, but if we consider the entire trajectory, our entire trajectory will be ending up at the same point. It's also going to have it's going to start here and it's going to end here, so its displacement will be 0. However, there is one other piece of information we know then. We used the last one because we wanted to calculate what our final velocity is, because we weren't given the final velocity. But the super secret technique here is you were given the final velocity. Because the motion is parabolic, because we can split this evenly in half, we actually do know the speed when it hits the ground. The exact moment it hits the ground must be the exact speed that it left the ground at, because that's what makes it a parabolic track, which means our initial velocity is 4, our final velocity is also 4, but it's pointing, its arrow, its vector arrow, instead of going up, is going to be pointing down, which means its final velocity is actually going to be negative 4.0 meters per second. Now, my first instinct when I was first in physics classes, and the reason this is separate, is because it really depends on how your mind works, whether or not this feels allowed to you. To some people, this just doesn't feel like something you should be allowed to do. Like, well, it's ending up on the same point. The calculations, there's no way that's going to work out and it's going to give me the correct answer. But as you can see by the fact that you are theoretically watching this video and I haven't just trashed the recording, no, it does work out, and we're going to prove it. So looking at the information that we have, we still can just use the same equation we used before. We can still use V equals V naught plus AT. We want to get t by itself because that's what we're looking for. So t is going to equal v minus v naught over a. Our initial is negative 4 minus our final was negative 4. Our initial was 4. Divide by negative 9.8. plug that into your calculator, which I already have, I believe. No, I don't. So we've got negative 8 because negative 4 minus 4. Sorry, let me move that. Negative 4 minus 4 is negative 8 divided by negative 9.8 is equal to 0.816326, which if we round to 2 sig figs, 0.82 seconds. And just for comparison, if I flip over this other piece there, 0.82 seconds, 0.82 seconds. Now, I know that this is way easier, so you might be frustrated that I didn't just show you this method to begin with. But honestly, it's just because I want to make sure that you don't have to do this. You can just use the logic of it's frozen or it's not moving at the top of it, and then it's falling back down. That just seemed last year to make more sense to the group that I had. Now, that was such a small sample size that obviously that might not work. If this makes more sense to all of you, I'll just use this example or this method for the rest of the year, or for the rest of the examples that we work out. But I just wanted to keep it separate for now, just in case that's going to continue being a trend. So definitely let me know if this makes more sense to you and you'd rather just do it this way, because if it does for everybody, that's how we're going to do it. Anyway, hope you have a good rest of your day. This is Mr. Diamond signing off from my super secret video. Have a good rest of your day, everybody. I hope to see or hear from you soon.